So we covered the C in CUSS. Now we're going to cover the first S in CUSS, which is spread, more properly called variability. Okay, so variance and standard deviation are two measures of this. We saw the symbols for this when we made our table for the whole population, sigma squared for variance and sigma for standard deviation, lowercase sigma, and S squared for variance of a sample, and S for the standard deviation of a sample. Okay, and so let's say we have 4 people go out for wings on wing night, and they eat these amounts, 27, 23, 29, 21. And so the typical amount of wings eaten by a member of the group, we usually say the typical amount is the average, and so that's 25. And so one thing that's interesting about 25, even though that's the typical amount or the center, none of those 4 individuals actually ate exactly 25, but 25 is the average number. So if a 5th person were to come and we were to be asked to guess how much they'd eat, 25 would seem like a reasonable guess. It's kind of in the middle of what that group is eating. So, like I said, some people eat more than that, some people eat less than that. And so there's some kind of variability in how many wings each person eats. And so we have a measurement of that. And so there are different ways to measure this. And so we talk about it mainly in terms of standard deviation. Okay? And so on average, let's see, this person ate 2 more, this person ate 2 less, this person ate 4 more than the average, and this person had 4 less than the average. Okay, so on average, they ate about 3 wings different than the average number of wings. Okay, so some ate more, some ate less, but the difference from the average was that. And the definition of standard deviation is the typical distance from the mean. Typical distance from the mean, and it's not typical distance from each other. So for standard deviation, excuse my typing, we'll call this the typical distance from the mean. Not the distance from other points or spread among different points. It's a typical distance from the mean. That's what we're talking about here. That's what we're looking for. Okay, so to calculate this, we're going to use our calculators a lot during this year, and we'll have some new functions that you might not have learned, and we're going to be working with lists a lot. And so on your TI, we're going to put those number of wings into our calculator. And so 27, 23, 29, 21. 27, 23, 29, 21. And so to get to the list, we do stat edit. Stat edit, get to a list. I put mine in list 3. You probably will put it in list 1. People generally feel more comfortable putting it in list 1, but I have it in list 3. And so now I'm going to quit out of that list, so I can quit, and I'm going to calculate information about that list. And so I do stat calc 1var stats, and I'm going to point it to list 3, second 3, and it's going to calculate some things about this, and we'll take a look at this. And so the first thing it calculates is x bar, which we said was an average. That's the sample average, 25. This is a sigma, big capital sigma of x, the sum of all the x's. So they ate a total of 100 wings. So the average person, the average number of wings was 25. The total number of wings eaten was 100. And this is the sum of x squared, which is a component of the formula for variance. When we go back here, we're using these different formulas. Here we go back, and here we are, and it says S, and this is supposed to be kind of a subscript, S subscript X, and that's a standard deviation of the variable. The variable is number of wings eaten. And then right below it is sigma, and again, sub x. It's supposed to be a sub x. And so they're two slightly different values. And the reason they're different is that the formulas for standard deviation are slightly different. The only thing that's different is in the standard deviation of an entire population, n, the sample size, is the entire denominator. And for standard deviation of a sample, it's n minus 1 is the denominator. Sample size minus 1 is all. That's the only difference between the two. But you can see that will provide a slightly different answer. And so if these 4 people were just a subgroup of a larger group, we would use the S sub x, the standard deviation of the sample. And if that were the whole population, we would use the sigma sub x, which is the standard deviation of the whole population. And as you can see, they're both around 3, which we said, on average, the typical distance from the mean, we said, on average, they were about 3 wings different than that average of 25. And so that's how you would figure it out on the calculator. And while we're in the 1 var stats, let's just explore a little bit. It says n equals 4, and n is the sample size. That's the number of people that we were looking at that were eating wings. And then if we arrow down, there's literally more than meets the eye. Remember when we did the box and whisker plot, we said we needed the 5-number summary? Well, this is the 5-number summary if we wanted to make a box and whisker plot. Min Q1, which is the median of the lower half of values. Median, which is the middle value in an ordered set. Q3, the median of the upper half of values, and then the max, which is the highest value. So, but for our purposes right now, we are measuring spread. So standard deviation, if this is a sample, and most of the time this year we'll talk about sample. And then other measures of spread are range. And so you could do max minus min for the range. And so we could say that 8 wings is the range of wings eaten. And there's also something called the IQR, the interquartile range, which is Q3 minus Q1. And so in this case, it would be 28 minus 22 would be 6. And so that is another measure of spread. Okay, so range, upper value, minus lowest value. And so we said that was 29 minus 21 equals 8 wings. And the interquartile range, IQR, is Q3 minus Q1. And so that's equal to, back to the calculator, 28 minus 22. Equals 6 wings. Okay, and so those are our most common measures of spread. Okay, so that's the first S in CUSS. We'll go to the next X in CUSS in the next video.